Yeah, hello guys. I'm Sunil. Today we'll speak about implementation of HashMap. Okay, in detail, like you know the put and get methods. Okay, the code for it. Okay, we'll design a class actually, like class my HashMap, and we'll give the same methodologies. Which HashMap has implemented internally, right? And we'll try to we'll try to get what are the best and optimize the time complexities. Okay, and what is the best, what is the worst time complexity. Okay, and what happens if a chain length crosses something like that, and what is the contract between equals and hash code. All these things we'll speak in today's class. Okay, yeah. So yes, can you see my screen, right?
Yes.
Yeah, now let me go with some theoretical thing. Okay, yeah. See, basically మనం ఏమనుకుంటున్నాను, what we used to think the hash map means something like a straight table, right? అంతే కదా, basically the general perception అంతే కదా. you know Here it's a key here from one side and values one side. Am I correct? అంతే కదా.
Yes.
That is wrong.
Our
Okay,
perspective.
there is general perspective, and even I, when I started teaching hash map, problem solving, even I teach the same way, because for your easy understanding. But it's not the case, guys. Okay, it is sometimes only. Okay, what is that? It is sometimes only. Okay, na? Okay, this is not the case. Okay, key value. Okay, the actual thing is that the structure is, it will be like this, guys. Okay, so there will be 16 buckets internally. Okay, now. So whenever you create any hash map, there will be 16 buckets like this. 16 buckets in the sense you can take boxes. Okay, to make sense. Okay, like that. Okay, now. ఇట్లా ఏవో ఉంటాయి ఇక, so on. Okay, 16 buckets ఉంటాయి, right? So here there is something called form factor. Okay, when the hash map has filled its size, and when the hash map is completed with its size, it will increase by 0.75, I think. Yeah, sorry. When hash map has filled its size, increased by a factor, by a form factor or factor, I forgot the name, by 0.75. Okay, yeah, its size will increase dynamically by 0.75, like that. Okay, na. So basically, what we place, so basically, whenever you are trying to do put operation, right? Suppose hm dot put off. Am I correct, guys? See, first I'm trying to explain theoretically what will happen. Okay, first they will also ask like this. In some cases, the interviewer ask, in system design rounds, the interviewer ask the same question in, like, can you please implement, okay, put and get methods on your own. Okay, how internally HashMap will behave. I'm not sure. Okay, so let me, yeah, one something like X, okay, hm dot put to something called Y. Okay, now. Now, guys, what will happen whenever you're trying to put some data? Guys, are you following, guys? So far, hello?
Yes.
Yeah, yeah.
Yeah.
Whenever you're trying to put some data, or whenever you're trying to insert some data, okay, it, whenever you're trying to insert data, okay, it will calculate the hash code. What's that? It will calculate the hash code of the key. What is that? Hash code. Okay. And Sumant, and internally there will be, some mechanism in the hash code method. Suppose the one is there, it will be multiplied by 100, divided by 200, or added with the plus, it will make sum of 5,000, something. Okay, some logic they will implement. Okay, that is none of our business. Okay, right?
Okay.
But
Okay.
it will give you each key, there will be a unique hash code, okay, na? Right?
Yeah.
It will give you some hash code, okay, right? Uh, so basically, by using that hash code, by using that hash code, we will calculate the bucket index. Bucket index. Okay, na? Bucket index means I have shown no this one. This one. Okay. And 16 ఉన్నాయి, right? 0 to 16, right? I mean 0 to 15, right? Like each bucket has an unique index, right? అంతే కదా? 0, 1, 2, 3, so on like that. అంతే కదా?
Yeah.
So a bucket index ఎలా calculate? Suppose we'll define some standard function. Okay. Suppose our bucket size is something like, 10. Let us assume our bucket size is 10. So you need to iterate between 0 to 9, right? So let us take int bucket index equal to hash code mod 10, right? Now the values are between 0 to 9, right? అంతే కదా? See, internally the JVM will calculate the hash code of that key, right? And JVM will calculate the bucket index by defining some standard function, right? Okay, na? Sumant, is that fine so far? Ramakrishna?
Yes. Yes. Yeah. Yes.
Jayashree, is that fine?
Yeah.
Okay. See, first it will calculate the hash code of the key, and then internally what will happen in Chapter. First, it will calculate the hash code of the key. From the hash code, will define some standard function, like how I defined in line 9. Okay, we'll define some standard function and will calculate the bucket index. Once the bucket index is done, okay, now it will form a node, guys. What is that? Node. So if you go through linked list, you can get a better idea. But I will explain. It's not an issue, right? So in the here, okay, na? Key and value, right? And next node address. అంటే అదంత అవసరం లేదు మీకు, like as of now, like next node address అని these three roughly these three boxes, or these three forms a node, guys. These three variables forms a node, okay, na? Forget about next node address. That will, once you come across linked list, you'll get a better idea of it. Okay. So see, now suppose for that key, we have the JVM has calculated some hash code. The hash code is 1000 around. By using bucket index, we have calculated the bucket index, right? Suppose the bucket index is 5, right? Now it will go to the fifth bucket index. It will go to the fifth one and it will attach as a node, guys, here. Is that fine? అర్థమైందా? Sumant?
Once repeat again.
Yeah. I will tell you. Let me draw neatly. Suppose the bucket index is 5. Okay.
Hmm.
After 2 operations, we got the bucket index as 5, right? Now that node will go to the fifth bucket. Okay. Fifth box. Let us assume the fifth box, right? And it will append here. Okay. Like that. Okay. Now after that, you're trying to keep hm dot put of what is that? 2, y. Okay. Again, we'll do the same thing. Okay, now. And again, we'll calculate the bucket index, right? Okay. Suppose for the 2, the bucket index is somewhere around 6, right? 6 kaadu 7 anukundaam. Let us assume that is 7. So it will go till the 7 and it will attach as a node. Okay, na?
Okay.
Node like that. This process will go on, guys. Now what if if 2 keys having the same bucket index? You got my question, right? Suppose somewhere around, okay, hm dot put of. See, the hash code might be different, but the bucket code is same, right, guys?
Yes.
Am I correct? Ante kada. Suppose somewhere, let us assume the bucket index for 3 is also 5. What will happen? Any guess, guys, here? See, my bucket index
7 place.
replace. Okay, that's a good guess. I appreciate it. Inka? రామకృష్ణ నువ్వు చెప్పు. జయశ్రీ నువ్వు చెప్తావా? ఎనీ గెస్? ఐ నో యూ గైస్ డోంట్ నో, బట్ గివ్ ఎ ట్రై.
Yeah, I also thought it will replace the one. It will replace the old one.
No, not at all. Basically, suppose, see, if it think practically, guys. If it replace, after that you're trying to do the operation of get. Okay, you were trying to get hm dot get of 1. If it replace, from where will it give answer, guys? Suppose you're trying to get hm dot get of 1. It should return my x, right? It should return the key, right? Okay, am I correct? If as you're saying, if I really replace, how will that give me the value of x? Is that making sense, guys? Hello,
No.
అర్థం కదా? See, అర్థమైంది కదా? అంటే నేను అంటుంది ఏంటంటే, లైక్ మీరు
Okay.
చెప్పినట్టు నిజంగా మనం రీప్లేస్ చేస్తాం అనుకోండి, వాట్ విల్ హ్యాపెన్?
Yeah, the value will be changed.
You'll get null pointer exception, right?
Yes.
Okay, you'll get null pointer exception. అసలు అది it is not making sense. Our whole concept of map is you're trying to get and you need to put, right? అదే కదా మ్యాప్. సో థింక్ ప్రాక్టికల్లీ. ఇంకా చెప్పండి ఏదైనా. రామకృష్ణ, ఐఎమ్ ఎక్స్పెక్టింగ్ సమ్ ఆన్సర్ ఫ్రమ్ యూ. చెప్పు ఏదైనా, బికాస్ యు ఆర్ బిట్ better, you completed something right earlier, so I'm expecting a mature answer from you. Mature గా థింక్ చేయి.
Sunil, stand up on the.
Okay. Sorry, Kani. Sorry, yeah, carry on. Okay, so let me tell you. Suppose 1 comma x, right, guys? It now, after coming to bucket index 5, it will check whether there is a hash collision or not. This will say, this meaning is there is a hash collision. What is that? If there is already a node at that, if there is already a node, okay, then it is said to be have hash collision. Then it is said to be a hash. What is that? Hash collision, guys. Hash collision means, అంటే ఆల్రెడీ అక్కడ ఉంది మనకి. అప్పుడు there are two choices, guys. Okay, whether to replace the existing one, or append. Okay na, guys? Is that making sense till here? See, అంటే ఇక్కడ మనం మీరు చెప్పినట్టు రీప్లేస్ చేయొచ్చు, ఆర్ యూ కెన్ అపెండ్. ఎప్పుడు రీప్లేస్ చేయాలి, ఎప్పుడు అపెండ్ చేయాలి, when we need to replace and when we need to append. That's the task here, guys. Okay, on basis of what you should replace, on basis of what you should append. అర్థమైందా? See, guys, till now we have seen two operations. One is hash code, right? Hash code method. Am I correct, guys? After that we have calculated the bucket index. This is second operation. Am I correct, guys? Now equals come to the picture, guys. What is that? Equals method. Now suppose the new node is there, no? That's 3, z as a form as a new node, right? Now your JVM will check whether the 3 is already in that chain of linked list or not. See, obviously, if it is the 10th node, obviously there might be 2 to 3 nodes appending like this. Okay, appending. So your JVM will check whether the 3 is already existing as a key or not. Okay, by using equals method. Okay, now let me write that point, guys. These things are very, very important. Okay, whatever I'm teaching, please, JVM will check whether the key is existing in that chain or not. Guys, is that fine? అంటే జస్ట్ అంటే ఇప్పుడు అంటే ఇక్కడ సపోజ్ ఐ హావ్ 1, x, 2, y at the same level లో ఉన్నాయి అన్ని. ఓకే, ఇట్ JVM will check my 3 is already there in the key or not. Like that it will check. అర్థమైందా?
Okay.
By using what it will check? By using equals method. It will check, guys. Equals method it will check. Okay. If it is finding a match, if it is finds a match, if it finds a match, okay, JVM will replace. మీరు చెప్పినట్టు అంటే ఇప్పుడు ఆల్రెడీ 3, X ఉంది. నౌ ద న్యూ నోడ్ is 3, Z. ఇట్ విల్ రీప్లేస్ X with Z, guys. ఓకేనా?
Okay.
If it finds a match, JVM will replace, guys. If not, if it is not, if there is no match, okay, JVM will append the node as a last node. Am I correct, guys? Append as a last node. అంతే. అర్థమైందా? Guys, is that fine? అంటే ఇప్పుడు ఏమవుతుంది? 1, X appending with 3, Y అంతే.
Okay.
అదేనా? ఇలా లైక్ దిస్ అంటే ఇట్లా ఇట్లా ఫార్మ్ అవుతూనే ఉంటాయి, గైస్. This is how internally it will work, guys. It's not like that what you think. Okay.
Yes, sir.
Okay, అదే అన్నమాట విషయం. So that is the matter.
First, we will calculate the hash code. First step,
Exactly. చెప్పు.
whenever we insert any input method to the hash map, at first it will calculate the JVM will calculate the hash code. First
Hash
step,
code of the
okay.
key. Hash code of the key. Okay.
Hash code of the key.
Exactly.
Next, by using that hash code, again JVM will only calculate the bucket index by
Exactly.
using some formula or something.
Yeah,
like
like there's some mathematical
Yeah.
formula, please. Yeah.
Then we will get some bucket index, and then there is a picture of hash collision.
Yes, exactly. So the
For
JVM will drag that node to that particular index, and it will see whether there is any hash collision or not. If there is a, see, now 2 cases. If there is no hash collision, happily it will append as a first node. If there is hash collision, then equals method comes to the picture. Now JVM will check whether my key is already there in that level of chain or not. If it is there, it will replace. If it is not there, it will append. Is that clear, guys?
There is hash collision. Like what?
Now JVM will see, okay, if there is a hash collision, means obviously 1 or more nodes will be there, right? So in that 1 or more nodes, my JVM will see, like my new node has a key as 5, right? Suppose let us assume key as 5. Now my JVM will check whether my 5 is there in this chain or not. It will traverse one by one. అర్థమైందా?
Okay.
If it found a match, it will replace. If it is not, okay, it will append as a last node, like that.
Got
You got it, huh? Jayashree, is that fine?
Yeah, fine.
See, even I don't want to teach everything at one go, because that's why this is. Let me show you my blog. I have got some picture on the internet. Okay. Sorry.
correction.
Yeah, for this I have written a separate blog alone.
That much important.
Yeah, this one only. See, student, what I told exactly the same thing.
Hash code of the key.
Okay, na?
Connected hash collision. If it is no, okay, simply no issue. If it is yes, there are 2 cases.
See, ఇది బకెట్ ఇండెక్స్ దే విల్ యూస్ సమ్ ఫార్ములా, లీవ్ ఇట్. ఓకే, ఇక్కడ హ్యాష్ కోడ్ కి మనకు మెథడ్ ఉంది. JVM will give a method dot hash code method simply. Okay, and I told by bucket index it will use some formula, and we use our own formula by implementing, right? It's not an issue. Now if there is a hash collision, yes sir, it first will see for no case, it will simply add as a linked list to the other hash node, right? Now key is already present. Sorry, if there is a collision,
Yes.
and collision అయినప్పుడు there are 2 chances. అంటే already key ఉండొచ్చు, లేకపోవచ్చు. If there is no key, it will append as a last node. If there is a key, it will replace. అర్థమైందా?
Yes.
Okay, is that fine, guys? Very frequent గా I'm getting thirsty, అంటే సమ్మర్ కదా.
Yes. Yes. Usually everyone will get that.
ఇంకా పీజీస్ లో ఉంటే వెరీ హాట్ యాక్చువల్లీ ఇక్కడ అసలు.
That's the main issue. If you are in institute, you feel more better, right?
అని కాదు, అక్కడ కూడా ఏసీ ఉంటది. ఇక్కడ ఏం లేదు, నాన్ ఏసీ. ఓకే, లీవ్ ఇట్. Yeah, this is the summary, guys. See, I have written the steps also here. Okay, you go through the steps. Okay, see.
But one now, ఇప్పుడు normal one, you said 1 comma x, 2 comma y, something 3 comma something we give like key value pairs, right? When this hash collision comes into picture, like when we are having the same value.
ఇప్పుడు see, suppose if my formula is suppose int bucket index equal to something, hash code mod 10, right? Suppose if it is my formula, now this formula will give same value for 33 and same value for 43, right?
Okay, yeah.
అంటే 33 same value, 43
different, we will get the same bucket index sometimes.
So now ఇక్కడ ఏమవుతుందంటే ఇట్ విల్ ఫార్మ్ ఏ కంప్లీట్ చైన్ అన్నట్టు.
Okay.
సుమంత్ ఇక్కడ చాలా డెప్త్ ఉంది. ఓకే, అండ్ ఐ విల్ టీచ్ అట్లీస్ట్ 2 classes ఫర్ దిస్ వన్ ఓన్లీ.
Sure.
ఓకే, డోంట్ వరీ. ఓకే, బికాస్ ఇక్కడ చాలా కేసెస్ ఉంటాయి. అంటే మనమే మన ఓన్ గా మనం ఈక్వల్స్ మెథడ్, హ్యాష్ కోడ్ మెథడ్ మనం రాయాల్సి వస్తుంది. అండ్ అక్కడ కొన్ని మల్టిపుల్ కేసెస్ విల్ కమ్. ఓకేనా?
Got it.
Okay, now this clear right till here? This?
Yes.
Now we'll go to the next step. Now this one I was asked exactly in Paytm, guys. The same thing. వాళ్ళు ఏమన్నారంటే, what they have asked is, suppose I have a big linked list. ఇట్లా వెళ్తూనే ఉన్నాయి, keep on going. అంటే every time I'm getting a constant hash code, right? అంటే constant hash code వచ్చిందంటే every time I'll get the same bucket index, right? Suman. Hello, Jaysh, are you there?
Yes, sir.
So నేనేమంటున్నా, what I'm saying is, suppose my hash code, suppose due to some particular, అంటే my hash code return the same value. Suppose suppose all the keys, right? Now we'll get not same value, but my bucket, you're getting bucket index the same value. Let us assume. Now
Yes.
you will get a long chain of linked list, ante kada?
Very big long chain, yeah.
So Paytm people, what they've asked is, in Java 7 we have some, that the Java people has upgraded this to a new feature. అంటే they have changed some implementation here అని చెప్పారు. అంటే ఇప్పుడు నాకు like suppose if I'm getting a linked list length of 1000, it's very hard to search, right? Am I correct?
Yes.
Right? అంటే like the get operation, suppose if you want to do get operation, hm.get of 5, now you need to check the entire linked list. Am I correct, guys? Now it is taking a lot of time, right? But
Right.
JVM 7 they have come up with a new feature here. What is that feature? They have asked me. Yeah, so what will happen is, internally there will be some threshold value, guys. Suppose your linked list length is crossing the threshold value, your entire linked list will turn to a tree. What is that?
Okay.
Suppose if your length is crossing the threshold value, if your length is crossing the threshold value, your entire linked list will turn to a tree, will turn into a tree, binary tree. See, this is also, binary tree is also concept of data structure. Okay, don't worry, but they want, at least you should know this feature, guys. Okay now? Okay, let me draw the structure of a binary tree. Okay, it's like somewhat like this, guys. Okay now? A binary tree, 2 nodes, 2 childs, okay now? Again 2 more nodes, like that. Like that. Jayshri, is that fine? Sumant, is that fine, Sumant?
Yes, Sunil. Fine.
అంటే ఇప్పుడు లీనియర్ గా స్ట్రైట్ గా ఉండే లింక్డ్ లిస్ట్ ని కాస్త వాళ్ళు దే ఆర్ మేకింగ్ ఇట్ బైనరీ ట్రీ.
Binary tree.
అర్థమైందా? సో దట్ ఇన్ లింక్డ్ లిస్ట్ మై సెర్చ్ ఆపరేషన్ టేక్ బిగ్ ఆఫ్ n, బట్ ఇన్ బైనరీ ట్రీ మై సెర్చ్ ఆపరేషన్ విల్ టేక్ log n. దట్ ఈస్ ద అడ్వాంటేజ్.
So this feature came into picture from
Java 7.
Java.
Okay, actually this Paytm, they have asked me the same question. Exactly
You
the same question.
answered?
Huh?
You answered?
I answered partially, but again after that I have made a good research. Yeah, 2 years back. Yeah, okay na? So from here, from a linear linked list, they will form into this binary tree, guys. Why they are making adjustment like this? Because you will get advantage in search. Okay na? You will get search while doing search. You will get advantage in searching. Okay. Searching. Your time complexity will drop from big O of n to big O of log n. N2. Guys, can you recollect in problem solving what is the time complexity which algorithm will take the log n time complexity, guys? Sumant, చెప్తావా?
Sorry, question.
I am asking, in problem solving we have discussed a lot of problems, right?
Yes,
I have
yes.
told you one algorithm which will take log n time complexity. What is that?
Binary search.
Exactly, binary search. Super, Sumant. Jayesh, is that fine? అంటే ఇప్పుడు don't think నేనేదో అంటే don't think I'm telling some bore theory. Don't feel like that. Every point is important, guys. Okay na? In these 2 classes, okay? Definitely, first question you will get the same, this question only. Lot of interviews, they have started with the same question. Okay? In multiple ways. It's not like they will ask something like straight away. They can twist this question multiple ways, guys. Okay? That's what made me to write this detailed blog. Okay? Jayesh, is that fine so far?
Yeah, fine.
See, I have written a detailed, see, yeah. See, from Java 8, guys. So see, the best time comes to put and get method is big O of n, and worst time comes to big O of n. See, this point is clear, guys. And if there is, if there is only single node at that bucket index, your time comes to big O of 1, right, guys? Ante kada? Hello?
Right.
If there is a length of big some chain is there, your time comes in big of n, right? Ante kada? Sumant, is that fine? Jayshri, అర్థమైందా?
Yeah, fine. Otherwise.
Sumant? Sumant, this is important point. Let's wait for a minute because see, Jayshri. So people will ask, what is the time complexity of put and get operation in HashMap? Okay. Hello?
Okay, someone has been let's join. Someone will join that in the
Parle. I will tell again. Okay. No.
call.
No issue. నీకు కాల్ ఉందా?
Yeah, I think someone is having call.
No issue. I will tell again. See, in interviews, people will ask, what is the time complexity of put and get operation? Okay. Most of the people will say big O of 1 and a hash map kada big O of 1 anukuntaru. It is not. You should say it will vary from big O of 1 to big O of n. Okay na? What you should suppose to say, my best time complexity is best TC is, sorry, not next. It is best time complexity is big O of 1 and the worst is big O of n. Okay na? Jesh, is that fine? But you tell them from Java 8, they have come up with a update that after crossing my threshold value, my chain of linked list, it will turn to a single linked list. Okay na? So that, sorry, single linked list binary tree, so that my time complexity is log n. Okay? Jay, it's fine.
It's fine.
Okay. So idannamata matter. Okay. Yeah. ఏమైంది? Yeah. Right. I feel I can stop here and yeah, because from tomorrow we'll go to the contract between equals and hash code. I will tell when this will come into picture. Okay, na? And from here I will start. Okay. Yeah, because someone is also not there. I want to stop here. Okay. See, today we have seen the introduction, the diagram, and how it will work. Okay. Only theory part we have seen. Okay. Tomorrow we'll go through this. When you should override. Okay. This equals and hash code method. Asalo ivi ekkada untayi, right? These will present in object class, guys. Okay. Okay. I will tell everything in detail, okay? Tomorrow's class, okay? Na? Let me stop
Yeah.
sharing screen.